What if the winter on the Great Plains fell to minus 30 degrees and never eased up? No walls, no cabins, only wind, ice, and open grassland. Yet one shelter kept entire families warm through nights that should have killed them. The tipi, a structure shaped by nature, engineered by survival, and perfected by Native American builders. How did they design a home that held warmth against the deadliest cold on the continent? Let us uncover the science hidden inside the tipi. Winter on the Great Plains never stayed still. One day the wind could sweep from the north with the force of a blade, and the next day it could shift suddenly, rolling across the open grassland with bitter cold that cut through everything in its path. For the native nations who lived here, the land was not fixed, and the weather was not predictable. In a world where temperatures could plunge to minus 30 degrees without warning, survival depended on a simple truth. If your home could not move, you could not live. The tipi was born from this reality. It was not a shelter meant to stand in one place for years. It was a traveling organism, a home designed to follow life itself. Food moved, the water moved, bison moved, and so the people had to move as well. The great herds of bison were the center of the plains ecosystem, and in winter, their migrations were the difference between full bellies and starvation. A family that stayed in one place too long could quickly find itself surrounded not by abundance, but by silence and snow. Mobility was not convenient. Mobility was survival. Because of this, every feature of the tipi had to serve motion. The lodgepole frame was deliberately chosen for its strength and its lightness. Long, straight, uniform trunks could be gathered, shaped, dried, and reused for years. They were tough enough to withstand windstorms, but light enough for women to lift, arrange, and tie quickly. In many tribes, it was the women who became the engineers of mobility, mastering the art of raising a home in minutes and taking it down even faster. The hide covering was equally intentional. Bison hides provided warmth and durability, but they were also flexible enough to roll, tie, and transport long distances. A family could pack an entire tipi onto a pair of horses using a travois, transforming what looked like a permanent home into a bundle of survival tools carried across the plains. The speed of this transition was critical. A shift in weather or a change in bison movement might require leaving within the hour. A slow, heavy structure was a death sentence. Mobility also shaped how people observed the land. They read the movements of clouds, the direction of the grass, the migration patterns of animals. They learned where river valleys froze early, where snow melted late, and where the wind carved natural paths across the plains. These patterns told them when to move, how far to move, and which direction promised safety. A tipi had to be more than warm. It had to be ready. When a storm approached, a family might dismantle everything and travel miles to reach a safer ridge. When the bison herds began to drift south, the community followed with their homes on their backs. And when the weather shifted again, they moved once more. This constant motion required astonishing efficiency. Poles placed in exact order, hides wrapped at precise angles, cords tied in ways that held firm in storms, yet released quickly when needed. To live in a tipi was to live in rhythm with the land. The home did not resist nature. It flowed with it. It bent, lifted, followed, and adapted. In the dead of winter, the plains punished anything that tried to remain still. But a home that moved could escape the cold, find food, and stay ahead of danger. This was the first secret of tipi survival. Before it kept you warm, it kept you alive by keeping you moving. And once the people mastered the art of motion, they could turn to the next challenge, choosing the right materials to survive what winter delivered next. In the harsh winters of the Great Plains, where temperatures could plunge to minus 30 degrees or lower, survival was never just about finding shelter. It was about choosing the right materials to build a home that could keep the deadly cold at bay. For the Plains tribes, building a tipi wasn't just an art. It was an act of survival. Every material chosen, every piece of wood, every hide, every strand of sinew was a calculated decision, ensuring warmth through one of the coldest, most unforgiving environments on Earth. The first material to consider was buffalo hide. But what made buffalo hide a strategic choice wasn't just its thickness or its ability to shield from the wind. It was its thermal properties, the way it responded to the environment. When the temperature dropped, buffalo hide naturally contracted, tightening its grip on the frame, reducing any gaps where cold air could seep through. The oil in the hide, combined with its dense texture, made it a natural insulator, trapping heat inside while blocking the frigid winds outside. However, even the thickest hides would be useless if not paired with the right frame. The lodgepole pine, light and straight, became the perfect material for the tipi frame. These trees were chosen for their flexibility and strength, able to bend and adjust to the pressure from snow and wind without snapping. Once they were cut and shaved into poles, they formed the skeleton of the tipi, an intricate web of support that not only kept the structure standing, but also contributed to the airflow inside, ensuring that warm air circulated evenly and stayed within the shelter. It wasn't just about building, it was about making the materials work with nature. Then came sinew, the tendon-like fibers taken from buffalo and deer. Sinew is incredibly strong, and its ability to contract when exposed to cold helped tighten the structure of the tipi. Unlike modern synthetic ropes that can snap under stress, sinew responded to the weather. When the temperature dropped, the sinew tightened, securing the hides and the framework, creating a seal that held against the relentless winter winds. Inside the tipi, the materials used on the floor were just as crucial to survival. Grass, pine needles, and moss were gathered to create the first layer of insulation, acting like a thermal mattress. They helped trap warmth rising from the fire and kept the cold from creeping up from the ground. Yet, survival wasn't just about keeping heat in. It was about keeping the heat where it was needed most. Every piece of material in the tipi was part of a larger system that worked together to manage heat distribution. The tipi's shape and structure were equally as important as the materials themselves. The round, conical shape of the tipi wasn't just aesthetic, it was designed to maximize airflow, channeling warm air upwards and allowing cold air to sink to the floor where it was pushed back out. The way the materials were layered and the way the structure was designed created an efficient system for retaining warmth, ensuring that the tipi's interior stayed warm even during the most brutal storms. But it wasn't just about building the tipi. It was about understanding the relationship between material and environment. The natural world didn't just provide shelter. It was a teacher, a guide that the Plains tribes learned to follow. They understood how the materials interacted with the land, how the hides responded to cold, and how the frame could withstand the forces of wind and snow. With every decision, they adapted, honed, and perfected their techniques for building a home that could withstand the worst of winter. When the first snowstorm hit, it wasn't just the cold that threatened survival, it was the wind. The fierce gusts that swept across the Great Plains carried with them a power that could destroy. Even the thickest hides and the sturdiest structures were no match for wind that could rip through them in minutes. But for the people of the plains, this wasn't a new challenge. It was one they had mastered, and the tipi, their ultimate survival tool, was their answer to the howling winds, the heavy snow, and the freezing cold. The design of the tipi wasn't an accident. It was a carefully calculated response to the brutal forces of nature. The tipi's most striking feature is its cone shape, and this was no arbitrary choice. In fact, the conical design of the tipi was the very key to surviving the harsh winters. The steep walls and pointed top acted as a wind deflector, forcing the fierce gusts to pass over the tipi rather than hitting it directly. In a world where wind could feel like a weapon, the tipi's shape was a defense mechanism. The angle of the walls created a windbreak, deflecting the wind downwards and away from the living space inside. By minimizing the surface area exposed to the wind, the tipi made it harder for cold air to penetrate. This simple, yet incredibly effective design reduced the risk of freezing during those long, brutal winters. But blocking the wind wasn't enough. The people of the plains had to find a way to manage the heat inside. The aerodynamic shape of the tipi was just the beginning of its ingenious design. Inside, the warm air created by the fire had to be circulated and distributed evenly throughout the space. The cone-shaped interior of the tipi was the perfect structure for this. As warm air rose from the hearth, the shape of the tipi allowed it to circulate upwards and then gently flow down the walls in a circular motion. This created a natural convection current, which ensured that the heat stayed inside the tipi and the interior remained warm, even as the temperature outside dropped to life-threatening levels. The smoke flaps at the top of the tipi weren't just there for ventilation. They were an essential part of the heat regulation system. These flaps served as smoke vents, allowing smoke to escape without letting too much heat out. The venturi effect created by the shape of the tipi pulled the smoke upwards and out while maintaining the interior temperature. During particularly harsh storms or when the wind became too strong, the flaps could be adjusted to control the flow of air. By narrowing or widening the openings, the tipi's occupants could ensure that the fire continued to burn at a steady temperature, even in the worst conditions. The control over smoke and airflow wasn't just a luxury. It was a matter of life and death. In addition to managing heat, the shape of the tipi also helped regulate humidity. Cold, dry air would naturally sink to the bottom of the tipi, while the warmer air would rise. This natural separation of hot and cold air kept the temperature stable, preventing heat loss and ensuring that the occupants could sleep through the night without being disturbed by the cold. The low entrance of the tipi was another key feature in this temperature regulation. By keeping the doorway small and low, cold air was trapped at the bottom of the tipi, while the warmer air remained close to the people inside. This simple yet effective design ensured that warmth remained at the level where it was most needed, near the sleeping areas. The floor of the tipi was the first line of defense. The cold of the earth could seep up through the ground, sapping warmth from the bodies of those inside. To fight this, the floor was layered with natural materials like grass, pine needles, and moss. These weren't just tossed on the ground. They were arranged meticulously, creating a multi-layered insulation system that trapped heat rising from the fire while keeping the cold from the ground at bay. Think of it as a natural, primitive form of radiant floor heating. The layers of organic material worked as a sponge for warmth, soaking up the heat from the fire and holding it close to the ground where it was needed most. But it wasn't just about insulating the floor. Sleeping areas were designed with the same purpose in mind, keeping the heat where it was most needed. Raised slightly off the ground, the sleeping platforms were often constructed from bundles of branches or woven grasses. This elevation made a world of difference, allowing warm air from the fire to circulate underneath and keeping the sleepers well above the freezing cold that might have seeped into the ground. Sleepers huddled together, and the shared warmth from the body heat of those nearby created a small but crucial layer of heat inside the tipi. It was a communal strategy, one that harnessed the body heat of the group to further bolster warmth. The walls of the tipi, made of tightly fitted hides and insulation materials like sod and rags, were another key to keeping the cold out. Sod, a material taken directly from the earth, provided an insulating barrier that not only kept out the wind, but also held the heat inside. The thick hides, stretched across the frame, sealed the shelter from the elements and worked with the sod to create a double layer of defense against the chilling air outside. The more layers, the better the insulation, and every layer worked in harmony to preserve the interior warmth. The most important part of the tipi's internal environment, however, was the fire. The hearth was the heart of the tipi, a source of light and warmth that could keep a family alive during the coldest nights. But the way the fire was used, its placement, its fuel, and how the air moved around it was just as critical as the fire itself. In the tipi, the hearth wasn't just placed in the center as many assume. It was strategically positioned slightly off-center to ensure a smooth airflow. This design created a circulating pattern where warm air would rise to the top of the tipi and then cascade down the walls, creating a constant, stable heat. The smoke, which could easily overwhelm the shelter if not properly managed, was vented through a small opening at the top. The careful control of this airflow kept the tipi warm without filling it with smoke. In particularly cold or windy conditions, the flaps at the top could be adjusted to control the flow of heat and air. The fire's heat wasn't just trapped inside, it was carefully directed and regulated for maximum efficiency. The tipi was more than just a shelter. It was a masterful survival tool, designed to withstand the brutal cold and shifting elements of the Great Plains. Every detail, from its shape to the materials used, was meticulously crafted to create warmth and safety. This ingenuity reflects the deep connection and understanding Native Americans had with their environment, turning nature into an ally for survival. If you found this glimpse into the resilience of the past fascinating, make sure to subscribe and stay tuned for more stories about how our ancestors mastered survival against the odds.